Okay, homework 7, number 5. So question 5 asks us to find f of z given that x is a discrete random variable with probability x equals 0, which equals probability of x equals 1, which equals 0.5, and y being a continuous random variable uniform in this interval. They also tell us that x and y are independent and that z equals x plus y. So this information right here is probably one of the most important pieces of information. So if x and y are independent and z equals x plus y, then f of z is equal to fx of z convolved with fy of z. So that's basically what our answer is going to be. But first, in order to find this, we need to find what fx of z is and what fy of z is. So fx of z is a discrete random variable, and they tell us that at x equals 0 and x equals 1 that it's equal to 1/2. So if I make this 1, this is 1/2 over here. So it's basically a delta at 0.5 for x equals 0 and for x equals 1. This is x, this is little fx of x. Fy is continuous random variable. It's uniform from 0 to 1. So this is 1 and it's uniform, so the height, this is also 1, should be 1 because it's uniform. So this is 1 here and this is fy of y. So to find the convolution, we recall that convolving anything with a delta just gives you the same function. So if I have a delta at 0, let's say the delta with area 1, and I convolve that with any function, I'm just going to get the same function at wherever it was. So in this case, delta, if this delta was at 1 and I convolve it with this, I would just get this back. If I convolve this with a delta that's at 1, this gets shifted over to the right by 1. If I convolve this with a delta that it has not area 1 but area 0.5, then it's as if I'm multiplying this thing by 0.5. So what's going to happen? So we have two deltas. So for the first delta, we get just the same thing back, but with the amplitude reduced by 1/2. So this is 1, this is 0.5. So we get the same thing, amplitude reduced by 1/2. So it's going to go something like this. Now we have another delta, and we convolve it with this. So what's going to happen is we're going to get this, but shifted over by 1. So where this guy drops off, this will pick up again. So it'll just be the same thing shifted by 1. So fz of z looks like this. It's basically the sum of two of these functions that have been decreased in amplitude and shifted. One of them has been shifted. So this is z. So this is what it looks like. How do I write this? It's fz of z is equal to 1/2 times u of x minus ux minus 2, where u is the step function. So it's basically we have u of x, the regular step function, we subtract from it the step function that would start at 2, and we get this. So that is how we get fc of z, and that completes this problem. I made a slight error at the end of my video. This shouldn't be x, this should be z, and the same thing here, this should be z. So what we get is 1/2 u of z minus u of z minus 2. I didn't mean x, I meant to put z.